Hello everyone, welcome to this video on Pearson correlation. We looked at chi-square test, t-test, and over. So let's now head on to Pearson correlation. So this is the student objectives to correlate H and HB level fibrinogen and platelet count. So you can see that the H is what? A continuous data, and the fibrinogen. Let's use H and HB. HB is what? Is also a continuous data. So you have two continuous data. So the student wants to know if H can influence HB level. So H now becomes the what? The independent variable, and HB levels become the dependent variable. So when we have both dependent and dependent variable as continuous data, which statistical tool we use Pearson correlation if it is normally distributed. Remember, we assume that all the data we're using for this practical are normally distributed. So let's head on to analyzing Pearson correlation. So this is the value for H. This is HB in your spaces. I have already presented them. I've done everything, the numeric data. So you go to analyze, you go to correlate, you go to bivariate. So usually this is always here, but because I've been here before, you take it here to this box. So you click on options if you want to get the mean or standard deviation, but in the absence of that, click on OK. So let's look at our output window, what spaces is telling us. Now this chart is not supposed to be here because I have done something here before. So this is what will come, this table, this is what you will see, this table, this 2x2 matrix. You see Pearson correlation, value of 0.59. You see the p-value is 0.686. Now Pearson correlation is always between 1 and -1. 1 for a perfect positive correlation and -1 for a perfect negative correlation, for a perfect negative correlation. So this value of 0.059 is a weak correlation, and you see that in the graph. Now this p-value is above 0.05. So it is not significant. Even if there is correlation, it's telling us that it is not significant. So if it is not significant, what do? We accept the null hypothesis and reject the alternate hypothesis. We are saying that this correlation that you're seeing is more likely due to chance and not really that H can influence HB levels. So let's go on to preparing our graphs for this. So we go to graph, we go to chart builder, click on OK. Because I've been here already. That is why. So usually this is what you would see. Usually you would see another graph presented here by default. I've been here before and I selected scatter plot. That is why you saw the scatter plot. So you click on scatter plot and this is what you see. Then you put your HB in the y-axis if that's what you want. You can as well put in the x-axis and you put your H in the x-axis. So click on OK. So the graph is processing. Now you can see this linear correlation. You can see this straight line. You can see that it's a positive correlation, meaning as HB is increasing, H is increasing, but it's very weak. The correlation is very weak. Now these dots that you see here stand for represent the values, the variable, or sorry, the values of the study. It means that there is a particular, if you see this dot, it means if you take it down to the H axis, you get the value for H that correlated with this HP value. That is what each of these dots represent. So from here, you can most times it's always interesting if you can present your correlation table with a graph. You can edit the graph as you want. You can copy it to your MS Word and present and interpret. Now, interpretation of the graph or of the correlation or Pearson correlation will depend on your school, will depend on the journal you are submitting to. So there may be no strict ways, there may be no perfect ways, there may be no one way of doing it. But look at this R squared value because most times when you are reporting it, you will need to present this R squared value, present the p value, and present the Pearson correlation value. So that is the end of our video on Pearson correlation. I really hope this was helpful.